Good morning, ladies. Today we're going to continue the previous lesson we had, which is relations and functions. Yesterday we stopped at this point, which is using vertical line test. We talked about this. We said the vertical line test is used to determine if the relation is a function or not. And if we're going to draw a vertical line, and if it passes through more than one point, it means it's not a function. So here we had A and C. The vertical line passed through 2 points. So it means that A and C, they're not functions. But B here, we made the vertical line and it passed through only 1 point. So it means that this is a function because it passes only through 1 point. Well, let's try different examples here. Let's try drawing the vertical line to determine if it's a function or not. So here, how many times did it how many points did it pass through? Here's 1 point. Oopsie. And here's the second point. So is this a function? No, this is not a function because it passed through more than 1 point. Let's try the second one here. Let's try, we have here 1, here 1, here 1, here 1, here 1, and here 1. So here each vertical line we made, how many points did it pass through? Here it passed through 1, 1, 1, 1, 1, 1. So this is, oopsie, this is a function. What's wrong? It means that this is a function. Let's try the last example we have here, which is, let's make a vertical line over here or a vertical line over here, or wherever point you want, because it's continuous. Here we made like more than one because it's not continuous, it's only scattered points we have. That's why in every point we made a vertical line. Here it's continuous, so we can make only one vertical line. So let's see here, how many points did it pass? Over here we had only 1 point, and here we only have 1 point. So this is a function. Which graphs represent the functions? It's B, A, and C. These are only functions. A is not a function. Okay, so let's go for the second idea we have here. We have something called function rule and a function notation. So let's read here. A function rule is an equation that represents an output value in terms of an input value. You can write a function rule in function notation. Shown below are examples of the function rule. So for example, if I have like a function or an equation here that has, this is the output and this is the input. Y is the output and X is the input. When we say function rule here, it's like f of x reads as f of x, or function of x equals 3x plus 1. Here, for example, if I told you x equals 1, it means f of 1 for this equation equals 3, and we're just going to substitute 1 in x to find the f of x. Now again, the f of x is the output, which is y, and here's the equation that we have. The independent variable x represents the input of the function, and the dependent variable f of x represents the output of the function. It is called dependent variable because its value depends on the input value. So again, x is called independent variable or value we have here, and f of x, it's the dependent variable. So again, the dependent variable here, which is f of x, it's called dependent because it depends on the value of x we have in this equation. Okay, so now we know what's the function rule and what's their function notation, and what is x and what is f of x. Now let's try some examples here. What is the output for the given input here? So they gave us this function and they're asking for what's the output for these inputs. Okay, so now let's try solving them. Okay, so let's now try solving this. This is the function that we have, and these are the inputs that they gave. So let's now just substitute here. So we're gonna say f of negative 3 equals negative 2. We're just going to plug in the negative 3 instead of x here. We're going to substitute negative 3 plus 5. Now using the calculator we have negative 2 times negative 3, which is 6, plus 5, which is 11. Let's go for the second input we have here. F of 0 equals negative 2, 0 plus 5. So negative 2 times 0, which is 0 plus 5, it gives me 5. So it means f of 0 equals 5. Let's go for the third input they're asking for. F of 1 over 4, which is negative 2 multiplied by 1 over 4 plus 5. Now negative 2 times 1 over 4 would give me negative half, plus 5 would give me, like, it's going to be 5 minus 0.5, which is 4. It's going to be 4.5. So these are the outputs for these inputs using using the f of x or the function notation. Let's check the answers we have here, which is 11, 5, and 4.5. That's right. So now let's go for the second example we have here. For f of x equals negative 4x plus 1, what is the output for an input of negative 2? So they're asking when we have what's the output when we have an input of negative 2. So now let's start solving. We're just going to substitute negative 2 instead of x here, so it's going to be f of let me just write it properly here. F of negative 2 equals negative 4. We're just going to substitute here negative 2 plus 1. So it's going to be equal negative 2 times negative 4 times negative 2. It's going to be 8 plus 1, which is the answer is 9. So f of negative 2 equals 9. This is the input. Let's check. 4, negative 2, 9. Yes, that's the right answer here. Let's go for the third, I guess, idea we have. Okay, so here if I gave you a word problem and you're gonna and I'll ask you for finding the function or finding the answer for the given function, for the function based on the word problem. We're going first of all to make an equation, then we're going to substitute in it. Okay, so let's read here. In case we wanted to write anything. Okay, so tickets to a concert are available online for $35 each, plus a handling fee of $2.5. The total cost is a function of a number of tickets of the number of tickets bought. What function rule models the cost of the concert tickets? So again, they want the total cost, right? So the total cost is called the total cost is the cost per ticket. Here we're having, again, here we're having 35 each. We have 35x plus the handling fees, which is 2.5. So let's now write it over here. Okay, so let's see here. He said 35 each. It means 35 each. We say each x as the variable here, the tickets that we have, plus a handling fee. So plus 2.5. 2.5. Now we want to find the total cost. it means this is y. So instead of y, we're gonna say f of x. And they're asking evaluate the function of 4 tickets. So they gave me an input of 4 tickets. Let's just now substitute here. It's going to be f of 4 equals 35 4 plus 2.5. Now using the calculator, we're going to have 35 times 4, which is 140. 140 plus 2.5, which will be equal to $142.5. This will be my final answer here. So again, here I made an equation based on this word problem. I hope like all of you practiced on the word problem, like opening videos, questions from the book, because like each word problem you have to know exactly what do they want. So again, we made this word problem and they were asking about what function Joule models the cost of the concert tickets. So they asked for the function first, then they asked us to evaluate the function if we had 4 tickets. We just substituted the 4 in the place of the variables we have here. Let's check our answer. $142.5. So again, T number of tickets. Oh, here they use T instead of X. Let's see, T is the total cost. So here they only substituted for 142. The cost for 4 tickets is $142.5 as we did. Let's go for the second example we have here using a word problem. Okay, so just let me copy it over there. Okay, so here you are buying bottles of sports drink mix for a softball team. Each bottle costs $1.19. What function Joule models the total cost of the purchase? So let's say the total cost is C of X. This is the total cost. It's equal to, it says here each bottle costs $1.19. So it's easy. It's going to be 1.19 multiplied by X. They asked us evaluate the function for 15 bottles. They all told us that if we have 15 bottles, what's going to be the cost or the output. Let's now just substitute C of 15 equals 1.19 times 15. This is 5. Okay, so using the calculator, we're going to have an answer of 17. What's wrong with this again? 17 point, okay, this is $0.85. The total cost of 15 bottles is $17.85. Let's check the answer we have. It's $17.85. A purchase of 15 bottles of sports drink has a total cost of $17.85. So this will be the end of this lesson. If you have any questions, please ask me during the class time. And have a nice day.